we wait for 2 more minutes and then we will start, okay? So you may prepare your stationery. And I suppose you have tried the question once at least. So I would just go through the questions directly, and especially I would remind you something very important. We did so many MC questions before. That's why we do more long questions. Some long questions we do today would be similar to the MC question in the common exam instead. Okay, so let's start. Don't wait for the others. First of all, this is a question talking about the refraction of light. So for the refraction of light, we need to know that there is an equation for us to solve the problem, which is the sine θ1. I may use this equation directly from now on. We don't use the one we learned in Form 3. We use the one we learned right now. This is sine θ1 times n1 equal to n2 sine θ2. It refers to two medium. One of that is medium 1, and in this case, the medium 1, I will take the air. The air is medium 1. The glass block is the air, it's the medium 2, okay? So the question giving you the graph sine alpha. Sine alpha is actually, you may call that θ1 in this case. You may just call this θ1 x. This sine alpha is θ1, okay? So I may rewrite the equation here. n1 sine alpha is equal to n2 sine beta. But we know that the air has a refractive index equal to 1. So that's why we may just cross out this. This is equal to 1, right? Can you follow up to now? So in the question, now let's read what the question said actually. It's given you a graph and you find a slope and use the slope and say is physical quantity. Now in this graph, we know that the slope is actually equal to the height divided by the width. So the height is equal to, you pick the 2 points. I myself usually take the points that are far away from each other. Okay, so that means the slope is equal to the height. We always find the slope in physics. So this is 0.62. Okay, divide by the width, which is 0.4. Okay, so from this, you may get the answer, 1.55. This is actually the slope. You don't need to understand anything from the question. You only need to find the slope directly. It's just a mathematical method. Find the height divided by the width, and then you can get 1.55, and you will have 2 marks only from this calculation. Yes?
Sure, but like at some points, the slope would be given it's different. Like for example, at 0.2, the slope would be different when I calculated.
The reason is the point is not exactly right at the cross of the graph. Do you agree?
Yes.
So there will be deviation. That's why we should take the largest value to take the slope. It can minimize this percentage error. Yeah, remember this, never use the small region like this. Use these 2 points, it's easy, but it will give a big error. Trust me, always use the whole region to find the slope, okay? Now, so the slope is basically the height divided by width, and since it's across the origin, it's also equal to sine alpha divided by sine beta. And according to this equation, it's simply equal to N2, which is the reflective index of the glass block. It's okay? So this is how the question is asking. We should be able to find out the relationship by using the equation here. At least you can write down this equation first and substitute the values, right? So let's have a look on the second part. The second part is find the slope of the graph in figure 2. Oh, sorry, I did already. Well, let me clear the screen. There's a guy called Philip. He predicts if alpha exceeds 50 degrees, total internal reflection will occur. State whether it is correct. You think it's correct? No, it's not possible. For the total internal reflection, okay, you have to satisfy 2 physical meaning is the reflective index of the glass block. Okay, now so for the total internal reflection, there were 2 conditions. Okay, the first condition is it has to be from large n to small n. That is optically more dense to less dense. But however, in this situation, we are sending the light from air to glass. You can see that it bends towards the normal line, it gets smaller. Do you agree? So that means it don't really satisfy this condition. So basically, you will just say no. The reason is the light travels from air to glass. Understand? This air is optically less dense, and glass is more dense. So compare the medium. It only can happen from glass to air, but not from air to glass. Is it okay? But if you don't understand what I'm talking about, you need to revise these parts, total internal reflection. What are the conditions for that? Okay, so this is the question 1. Okay, now, so let's continue to the second one. So you may stop me if you have any question. Someone say someone find this. You may find sine -1 over n. You can find the critical angle, but in this question, you don't need to bother about this critical angle. The reason is, even though the angle is larger than the critical angle, it won't happen. It don't satisfy the condition. Light travels from more dense to less dense to make total internal reflection happens. Okay? So that's why I mentioned 2 criteria. Anyone is not matching, you don't see total internal reflection. Okay, let's continue to the second question. Now, you will see a question in long question about the Newton's third law. And also then you will see a question in MC question about the Newton's third law. So I will make use of this question to revise what is the meaning of the Newton's third law, okay? Someone asks what is the meaning of the air pressure? Or someone say it's because of air pressure. Okay, now, you need to understand, in order to apply Newton's third law, there are some keywords that you must mention, okay? The thing you need to mention is object A exerts a force on object B. All right, this is something called action. A give a force to B. And then you must mention by Newton's third law. All right, I want to see you guys when you answer the question, you use these sentences. Object A exerts the force on object B by Newton's third law. Object B also exerts a reaction force on A. Or use these words, this wording, exact wording to answer this. And these two forces should be the same. This F, I call it F, okay? And this reaction force is called F pi, okay? The relationship is they are having the same magnitude but opposite in direction. Understand what I mean? Now, so this is the Newton's third law, how we should express our concept in answering a long question. But the MC question will be giving you 3 pairs of forces in different cases. You will see some diagram, and they will ask you, are these 2 forces action and reaction pair? The skill you need to apply is like English. They're object and subject and object, right? There must be a pair of subject and object, A to B, and then B to A. If the forces satisfy this example, this condition, I will call that is action and reaction pair. I give an example. If I'm standing on the floor and there are 2 forces, one of that is the weight, and the other one is the normal force acting outward. Okay, this is the normal force. Are these 2 forces action and reaction pair, and why they are or they not? They are not. Can someone try to answer me?
So what was your question?
Now, okay, my question is, there are 2 forces shown in the diagram here. One is the weight, the other one is the normal force. Can you tell me whether they are action-reaction pair?
No.
Okay, yes, your answer is correct. How do you know that they are not action-reaction pair?
I just know it.
Now, we should try to consider in such way like this. So let me use red color, red. We look at this weight. Who is the force given to what object? You know, they're all subject and object, right?
Mass
The
and
weight
gravity.
is from the earth. Exert a force to the person, isn't it? But the normal force is the force from the ground to the person, isn't it? Is this relationship satisfying these conditions? They are not, right? They are acting on the same body, and it's not subject-object relationship. Do you agree? There are 3 objects here. The first object is the earth, the whole earth, and the second object is the person, and the third object is only the ground. I'm not talking about the whole earth, it's only the ground, the position the person is stepping on it. Is it okay? So they are not action-reaction pair. So this is the this is something you should be able to handle in the MC questions you will see in the exam. Okay. I'll give you another example then. Let me clear this. Same thing. I'm standing here. You already know that there is a force acting outward. In it, this end is by the ground to the person. So what should be the reaction force of this normal force? Remember the rule, A to B is F. B to A is reaction. Yes, it's the people exerting a force on the ground. All right? So let's say this is the ground. So there is a force acting on it. I will call this a normal force also, but it's acting on the ground. So you may see this, the N pi is actually the force by the person to the ground. So this is action-reaction pair. So I hope you can understand what I'm talking about for the action-reaction pair. It's just like identifying that it's not really difficult.
So how about friction? Like, for example, like somebody is running and then is friction a reaction?
Yes. Now let's say,
Yes.
let's say maybe I'm pulling an object like this. Okay, there's a friction here. Okay, now for this friction, is actually the force from the ground to the block, isn't it? So the reaction of it should be the block giving a force to the ground. Friction is always neutral. Okay, if you provide a friction on one object, that object will be also giving you a friction. That's why if you have tried to use your normal school uniforms, the black shoes, in the gym to play basketball, you may see some mark on the basketball court. Do you ever see that? The reason is the ground tries to give you friction to slow you down, but at the same time, the floor, you are providing the friction on the floor. So that's why you leave a mark on that. The force is on each other between the contact surfaces. So that's why there's action-reaction forces for friction. Okay? So that is a rule in the nature. All the forces must appear in pairs. You can't find one force existing alone. Okay? Now, so let's try to answer this question. There's some compressed air, and there's a trigger. That means when the trigger is not open, it will be airtight inside, right? So there will be maintaining a high pressure of air inside. But once I open this trigger, I pull the trigger, so the compressed air would exert a force on the water. So that's why you need to answer like that. Okay, let me type instead of just, okay now. You should write like this. The compressed air exerts a downward force. You may also highlight the direction. Force on the water, or to expel the water. Okay, this is the downward force acting on the water from the compressed air. So at the same time, yes?
What do you call is there anything like, you know, when compressed air and less compressed air, and then they like move each other to make it like balance? What do you call that? What do you call
You mean
that?
at balance?
Like, for example, there's a compressed air in a box, and then like normal air, and then when you put them together, it's like kind of be equal, like heat, like the air
Now,
pressure.
it depends on whether there is a connection in between the two systems.
Yeah, the connection, and then you open the connection with that.
Or the compressed air would be escaped from its chamber.
Yeah. So what do you call that?
It's a flow of air, actually. If you have to, the flow of air from the more dense, more compressed region to the less compressed region. And at the end, it will stop when both chambers have the same pressure.
So is there a law?
There would be a law we learned in the chapter 5.
You're asking us stuff that is not even.
So it's not really asking the pressure, okay? So let's go back to this question. At the same time, what you should write, because you mentioned compressed air, this is one of the terms, and the other one is water, right? So what you need to write is, at the same time, the water exerts an outward force, which overcome the weight of the rocket. Okay, now there are two forces. One of the force is the water, the air press the water down. The other one is the water push the air out. So at the same time, if the upward force is larger than the weight, according to Newton's second law, according to Newton's second law, there is an acceleration upward. Rocket. Now I missed something here. I should also write according to Newton's third law. I should not use this. According to Newton's third law. So I need to highlight some of the important words. First, this is the subject, okay? Wait, someone is entering the classroom. Now let me do like this. This is the subject, and this is the object. At the same time, you may see that the subject-object will interchange. Okay. This rocket is including the compressed air. You may just treat these two as the same thing, right?
Sir,
Because yes.
can I actually apply the Newton's third law onto the force of the rocket and the ground? Can I apply that?
Oh, you can't, because in this case, it's from the air to the water, and the water pulls the air upward. So it's not related to the ground.
Nothing related to the ground? Like because the air like exert a force onto the ground, so that's why the rocket accelerate upwards?
Not really in this case. It's lose contact immediately to the ground, basically, right?
Okay.
So there are two laws actually. The first one is action-reaction pair. This Newton's third law. The second one is why it rises. Right? When it rises, it's due to the Newton's second law. Is it okay? So this is the answer for the question 2. I'll upload the answer, the model answer, later on the Google Classroom too. So you may have a rough idea what we should pay attention. So in this question, I think most important thing is the Newton's third law. Be able to apply and be able to write down. Law of conservation of momentum is actually related to Newton's third law. We didn't learn momentum yet, but that momentum thing is from Newton's third law. You may use Newton's third law to answer this. Okay? Now, so I continue to the next one. Okay. We did this before. Do you have any idea? It seems I put it in test before. I'll just go through this quickly. In order to answer this question, find the average speed of wave between P and Q. You need to use the information given. That is 20 meters from P to Q, right? And it takes 4 seconds to travel from these 2 points. And then you may just find this speed directly from distance divided by time. So that's why it's equal to 20 divided by 4 equal to 5 meters per second. This is the speed of the wave. Very simple. But I want to remind you, I want to do this question to you with you again. The reason is only because this is a question related to refraction, okay? You see from this point, it has a certain depth. The depth doesn't change along P to Q, but it starts changing after this point. The depth change gradually, getting smaller. So when the depth goes smaller, you must understand it is associated with the velocity of the wave. It's getting smaller also. And at the same time, the lambda is also getting smaller. So what you need to do is to draw this wave with even spacing wavelength, now same wavelength, but later on, it got narrower. Something like this. But I think my drawing is not good enough. It's too packed. Like this. Oops. You make it very packed at the end. So you see that it's gradually changing from large wavelength to smaller wavelength. The reason is the speed decreases. Why the speed decreases is because the depth is decreasing. All right. Now, so you will see a question about water wave and change in wavelength. You should be able to understand is change in depth. So this is what you do. Not only this, in the long question, there will be a question asking you about the speed and the wavelength relationship. In fact, you may use this equation. Lambda 1 over lambda 2 is equal to V1 over V2. You may write down this equation, or if you understand one of them, okay? From a fast medium, it has a certain wavelength and a certain speed. And then you may be given another wavelength, and then you need to look for the change in the velocity in that medium. Something like that. Is it okay? Now, so that's the question A and B. So let's continue. The last one, what is this phenomena? It's just I talked about that already. When there's a change in medium, there will be a change in speed, and this is refraction, okay? Refraction. So very easy. For the first three questions, they are very short questions. But starting from this one, it's a long question. You see there's so many parts, A, B, C, D, and A, C, I, C2, CII, BI, BII, so many questions. So let's do it one by one, step by step. It's a bit difficult for this question, but try to follow. I will give you some hints for the exam also. First, it's like a change of unit, okay? You need to show that 100 kilometer per hour is equal to 27.8 meter per second. So you may just write down this. V equal to 100 km per hour. Now you need to convert that into meter per second. First, you need to tell how many meters in 100 kilometer is 1,000 meters. For 1 hour is equal to how many seconds? You just convert that into 60 seconds times 60 minutes. Okay, I convert the kilometer per hour into meter per second by using this method, which is equal to 100 times 1,000 divided by 3600. And then by the calculator, you get the same answer. It's like every time you change the kilometer per hour into meter per second, you just divide by 3.6. It's a skill, divide by 3.6. The reason you divide by 3.6 is from this rectangle. Okay, now it's very simple. You got this speed already. And the next step is find the total KE of John. John, it's you. You have a car, you need to find the KE of it. So since you already convert this into meter per second, when we find the KE, we will just simply use this equation, KE equal to half mv squared. Always use meter per second in this equation so that the result will be in joule, okay? So you will just put half times 1400 times 27.8 squared. So then you may use calculator to help you. Okay, the answer should be 5 joule. Okay, this is the KE. Any question? Do you think you can handle this? It's not very difficult, right? I mean, up to this moment. So after you know the KE, there is another part asking for the FH power of the car when it is accelerating to this speed. So that means at the beginning, it was 0. It was 0. At the end, it becomes 27.8 meter per second. When we talk about output power, we must find out the work divided by time. Surely where is the work from? It's from the engine, okay? It pushes the car forward. But when the engine provides energy to the car, you do find out this amount of energy. You can ask the engine, but the engine will not tell you what is the amount of energy it has. The only thing you can find out is its final KE, right? So I will assume that the engine provides the energy and all converted into kinetic energy. So that means this work will be equal to the change in KE. Let me write one more step here. Now, so you need to ask yourself whether you know what I'm talking about here. This work is equal to the change in KE. There's no energy loss because it is no friction. I assume there's no friction. Secondly, it doesn't change in the height. So at the end, there's only KE gain in this situation. So then you may divide it by the time it's given, 9.3. So you may substitute the value you have. So after this, you may find the answer, which is equal to 58,000. Something like this, okay? So that is the answer for the part B. Now, make sure that you know what's going on, because when we are talking about a question involving work or power, it's always like that. Okay, let's check the message you got. Is that me? What TUPAC was that? Okay. Now we got part A, part B, and now the part C is asking. There is a similar road test, but we conduct this into an inclined road, and now the car takes more time to accelerate from the rest to the same speed. So assume the output power remain unchanged. That means the amount of energy in each second from the car is the same. So why is it taking more time for accelerating up to this level? The reason is it's not only KE, but also PE when it travels up, right? And maintain the same speed. So before you only need to provide energy to give sufficient KE, but now you also need to provide energy for increasing the height. So that's why it takes more time to finish. So you may write like this, yes?
Can I write it's due to gravity?
You can't answer only by this gravity. You must use this equation. Look at this.
So I wrote gravity is an opposing force.
In that case, yeah, you can do that.
Sure, because if I use this, what if the inclining, it's declining, the slope?
If you answer in that way, you need to answer like you need more force.
Yeah.
Yeah, and it travel in a longer distance also, because it accelerates slower, right?
So
if both, yeah,
okay, then
you can use both methods to answer, but I don't prefer you to use this right now because we didn't learn the inclined plane yet. Do you agree?
When are you gonna teach Every time when I ask you questions, you say we are gonna learn, and we never
Yes,
learn.
yes, we didn't learn all the topics, right?
Then
But
teach.
but in fact, what you say is it tells the nature of this subject. In these parts, force and motion, there will be more than one method for you to answer a question. So usually when we look at the marking scheme, I will send you also. You may see there are different methods to answer the questions. But now I only focus on the one we learned already, which is the energy, okay? Now, so you may just compare with this equation. And the one we used before is only P equal to change in KE divided by time. Since the power are the same, and now for the bottom part, you get one more term here. So that's why in order to have the same value, this time should be also bigger. This is how we answer this question, okay? Okay, then last, find the increase in height of the car after accelerating for 12.2 seconds along the inclined road. So how can we find the height of it? Do you know how to do it? Just make use of the math. So clever, it's math. Exactly. Exactly. Now, so we may do like this. We got the power already before, which is 58100 watts, isn't it? And then we know that in 9.2 seconds, wait. Times 9.3 seconds. This term would become KE. This is what we did before. Power times time equal to KE in the part A or part B. And after this, if you need to climb up to a certain height, I have the same power, 58100 watts. But what is the remaining time for only giving the power or the energy in PE, which is equal to 16.3 minus 9.3. It's 13.2, sorry. So that means in this 16.2 seconds, I'll be right here, 16.2 seconds. 9.3 seconds is for KE. The remaining is only 7.1 seconds. Is for the PE, isn't it? So I mean, right, like the PE is equal to 58100 times 7.1, which is equal to mgh. You just look for the heights. And the mass is also given, 1400. And G is 9.81, and this is H. You know the answer. Okay? Huh? 6 point something so small? It's not really.
Sir, I got 29.
Oh, it's not 6, it's not 7.1. It should be 6.9, right? 29. Yeah, correct. It's around 29.
Then why did you say 6.9?
No, I mean this one. I did wrong calculation. So stupid. I mean the time remaining. It's not 7.1, it's 6.9. It's like 16.2 minus 9.3. It's 6.9 for the time. Can you follow? Right? So yeah, we are using the equation about the KE plus PE equal to power times time. Learn from your mistakes.
Yes, man, there's already a mistake.
Pythagoras theorem, we don't have the angle, and we don't have the base, and also how long is the inclined plane. We can't find the height in using Pythagoras theorem. We don't have that length. I only have the power and time for this question. Okay. Okay, let's continue. We can find by uniform acceleration formula. Time, speed. Okay. Oh yeah, you can also do like that, but it would be very complicated. It take much longer time, right? Someone asked if we can use the sine theta cosine theta thing. Yes, we can still use it, but first you need to find the acceleration, and after the acceleration, you need to also find its pushing force, and also if there's any friction or no friction, but only it'll be much more complicated.
Yeah.
The answer is 29 meters.
First, somebody
Yes.
is asking, what will the exam be easy?
I think it's not difficult. This is what I can say. But surely you don't understand what I'm talking about today and also in the previous lesson. What I'm worrying is like, even though I keep talking about this and that, you don't understand this at all. That would be the main problem. Okay, now let's move on to one more question and then you take a break. Okay. Let's clear and go to question 5. Oh, sorry, not yet question 5. It's 4D. We would have a break after question 5. Right now, the car suddenly stopped due to a traffic accident, and he braked the car and with a skid mark on the road. And then the police investigate the case, and he found that the skid mark has 30.5 meters. Surely you're smart, right? This is actually the displacement. And the frictional force between the tire and the surface is given by this amount of forces. So describe the energy involved when the car is braking. So what energy at the beginning when the car is traveling? Before, when it's traveling, surely it has KE, very good. And after, no energy is stopped, right? On the level road, no KE, no PE is 0. So that means there is some energy loss by the car. Originally it has KE, but now at the end it has nothing. So where is the energy goes? It actually goes to the heat. We'll say that it will become the internal energy of the road and the tire. Or the tire and the road. Yeah, friction. You're correct to mention friction, but not about energy. Friction is a force, right? You are actually having a work done against friction and convert the KE into internal energy of tire and road. This internal energy means the temperature will increase. You know, friction can generate this. The reason is you are converting the KE into heat energy. It's okay? Surely, if you mention sound energy, it's also okay because when there's a skidding, you also hear sound, right? There will be some energy converted into sound, but you may just mention one of that. The KE is converted into the internal energy of tire and the road or sound energy. Anyone will do. And then the last one. John claimed he's driving at a speed lower than 7 km per hour.
So he's
One is enough. Because when we describe the change, he should mention from which energy to what energy. That means you're answering 2 things already. You need to mention the original KE and also convert it into somewhere else. But I myself prefer you to use internal energy because it has more energy. Running sound could be one possible answer, but to be honest, internal energy should be much higher than the sound. Okay, last.
John is lying. John is lying.
John is lying. Let's see. Let me answer just me the first. I repeat once again. In this question, you are trying to describe the energy involved when the car is braking. You should first mention what energy you have at the beginning. You should first mention there's a KE of the car, and it will convert it into the internal energy of the tire and the road. Okay, you may say due to friction or due to work done against friction. So that would be okay. The last one, John is saying that his speed is lower than 70 km/h. So explain whether he's telling the truth or not.
He is a liar.
He's a liar. Okay, how do you know that?
Sure, according to my calculations,
Yes.
that's why.
Okay, now make use of the right-hand side to answer. Make use of this to answer. What is its original KE? What is its original KE? It should be half mv squared, right? You will write down the original KE. Let's say according to John, you will use half. Originally is 70 mv squared, which is equal to half 1400 times 70 squared. Now, if you do like that, it's wrong because the unit is not matching. You need to convert this into meter per second. That's why you need to divide 3.6. That is the skills we learned in the first part. You always divide by 3.6. Okay, so let's calculate this. It's 1400. 1400 divided by 2 times 3. What I'm doing? Screwing around. Okay, I got this 242. See, so stupid. 26466 joule. Now, this is what John claimed that the energy he should have is 26466. But in fact, the work done against friction should be equal to friction times displacement. Someone told me at the very beginning from the chat room already. This is just me to say that. Yeah, F times S. Yeah, correct. So you will calculate this value, which is 11200 times 30.5. Now you will see how's this value. 11200 times 30.5 is 4341,600, right? Did I calculate this wrong? Let me calculate this again. 700 times 17.
Sir, I think you missed a zero.
Which one?
It
You mean here?
It should be 264,660.
Okay, that is right.
Yeah.
Good. Thank you very much. Now, so for the frictional, this it should be equal to. Let me calculate. 36 something, right? What's T? Where's the T? Where's T? I don't have a T, right? Now, so you got two energy. This energy is the energy given from the road or taken away from the road. And John said that he has only this amount of energy. So it should be able to stop the car, right? Within this range. But you can see that it shouldn't be 30.5 meters that much. I mean, if the speed is 70, it takes less distance to finish that. So you may say that John is telling lie. Okay, internal energy of the tire and the road is T down. A temperature is not really. I'm talking about it will become temperature. This internal energy become temperature. Now, so I will try to do this again on the blank whiteboard here. Now I'll try to repeat once again. John said that his speed is 70 kilometers per hour. And then he come to a rest. So the KE loss is equal to half mv square, right? Is equal to 2, I forgot that's the number, I think. Rosemary, can you tell me what's the value? 26.
264660.
Now, this is the amount of energy John claimed he should have. And there is a work done against friction, which is equal to, according to the question, is 1 something. I forgot again. Let me check.
Sir,
What's it?
34160.
11200. Okay, thank you. That is right.
Yeah.
So equal to 3 watts.
341,600.
Very good. You compare these two numbers. If the work done against friction is that much, it shouldn't be that small speed. It should be much higher speed. If you need to find the actual speed, we can also find that. The question doesn't ask that, but we can also find that. These values should be equal to the half mu, the actual value. Understand what I mean? So you may find this actual value by using 341,600 times these two, divide by this mass 1400, and then you take the square root. This is the actual value. So you have 22.1. Just copy from Jasminder. If you find this speed, you may convert that back into how many kilometers per hour by times 3.6. Okay, so it would become 79.5 kilometers per hour. So this is the actual speed of John. He's speeding a lot, much higher than the speed limit. You know, usually on Hong Kong's road, the limit is 70 kilometers per hour normally.
John is a liar.
John become a liar.
I told you he was a liar.
He's very sincere and polite. He's such a gentle.
Sir, in front of you he is like that, but with us he is not like that.
Really?
Yes, sir.
Let me
Figure it out. He has two faces.
Two faces. He's so polite. But you know, Joe Ban is always talked a lot in front of you guys, but he's so humble to me. I'm so appreciate that.
Thank you, sir.
Yeah. Okay, so do we need a break or we continue? Wait now. Short break. 5 minutes. 5 minutes. No Johnny things is not good. Okay. Now, so let's continue. 5 minutes. We come back at 5:30. Okay. I'll go drink something.
Don't drink alcohol, and then you will mess up all the questions.
Stuck in the washing machine.
Sir, that's why he cannot hear us so clearly. That's why he's keep on asking you to repeat. He's stuck in the washing
Oh,
machine.
really?
Yes,
Oh, I
sir.
see.
Sir, I know he's very skinny and you think he would not, but the hole of the washing machine is very small. Sir, I need to help
you guys are very creative.
Thank you, sir. I know that.
What daily wage is what was that? 周班
Yes, sir.
scenes fooling around.
Sir, see, Saplo.
Why you guys always like that Johnny?
Sir, he's an astronaut. He's my idol. I want to be an astronaut.
What astronaut? Do you know there was a junior form kid? He lied to the teacher. He's so famous and so great and with donation this and that. And at the end, the teacher asked the parents to talk about this Johnny's scenes, and he's in big trouble.
That was the teacher you. Were you
Huh?
the teacher?
I'm not
Oh,
the
were
one.
you-
I'm not the one. I heard about that.
Yes.
In Form 2 or Form 3, I forgot. It's like before the summer holiday.
Sir, but just
He talked to the miss like that. You know, the miss doesn't really know that. And think, oh, he's so great person. And she tried to search from the Google and he found what's going on.
Sir, once in Form 3, we did that to a teacher also.
Really? So what's the consequence? Anything happen?
Nothing.
Oh, yeah. Oh, let's continue. So we may need one more section tomorrow morning. So let's try to finish few more questions and we'll continue tomorrow morning. Question 5. Let's go back to the question. Okay, now, I can't tell you the question exactly what is happening, right? But what I can do is using a question similar to remind you something important. So in this question, you see, it's very typical. Describe the motion from 0 to 40. So that means in this, whenever you're trying to describe a motion, we must first divide the motion in different parts. Okay, now so in this question, there are 3 segments. Where's the pen? The first segment is here, up to here. The first 10 seconds. The second segment is from 10 to 20. This curve. I don't draw on the graph because it's so messy. I just highlight this, okay? And at the end is from 20 to 40 seconds. 2, 3, 4 o'clock would be fine. What do you mean? Why afternoon? Why don't we do it in the morning? I'm not free in the afternoon. I need to go to Finland for a school visit. So I will do it in the morning.
Sir, at night.
At night, it's too late. You have exam on Wednesday, right?
Sir.
What happened to you guys? busy in the morning?
Sure,
Sleep late?
Overslept and then.
No. Wake up earlier. Adapt to the morning early time. You did come back.
I deserve to sleep more.
No, morning. I will do it morning anyway, but I will put the video right after the lesson. It's up to you, okay? Then let's continue. See, now this is a
Sir.
Are you okay?
Sir, will you put the video of this lesson?
Yes, I will.
Okay, thank you.
Yeah. Now, so this question, there's 3 segments. And also look at the axis at the beginning. It's a displacement time graph. So if you see there's a flat region here, no change in displacement, what you can tell is this is he is stationary. Right? Yeah, or at rest. In last lesson, I talked about curving up or curving down. This is a curving up. means it's accelerating. Okay? It's accelerating. Increased velocity, very good. Your slope is increasing. You can see the velocity is increasing. And the last part, you see a straight line. This is a uniform velocity. The third one is uniform velocity. So remember, always remember, curving up is accelerating, curving down is decelerating. Okay. And the part B, find the average velocity. Average velocity. That's definition, okay? Average velocity equal to displacement divided by time. Displacement, wrong spelling, divided by time. So check from the graph. What is displacement? Usually compare with the starting point and the finishing point. He was at 50 meters, and at the end he's at 300. So displacement is equal to 300 minus 50. This is 250. And the total time taken is 40 seconds. So which is 250 divided by 40. So it's 6.25. Yeah, correct. 6.25 meters per second. This is the average velocity. Very easy question, right? So once again, read the axis for xt graph. So st graph, you may use the slope to find the velocity. Curving up means acceleration, increasing slope. Okay, let's go to the next question. Okay, this is a difficult one. We did that before, I remember, isn't it? Let me clear everything first. Now, is it really difficult? I would say that some parts is difficult, but some of the parts are very easy. Kenneth might die. Not really, only a few meters, 10 meters only. Trust me, if the water is having a certain depth, he will die. No, he won't die, I mean. So Kenneth, mass 60 kilometers. It is coming from rest at the beginning, means u 0. And then he jumped, not jump down, he come from rest and fall down to the water. So find the potential energy when he stand on the platform and take this level. The ground is 0. So that means PE is simply equal to mgh. I think everyone should get this one mark. 60 times 9.81 times 10. But this is the past paper of the old syllabus. So when you see the marking scheme, I send you later, which is in the 10. How can you slow down? Later on, when he reached the water will give a friction or water resistance to slow it down. Okay, so let's calculate this. 60 times 9.81 times 10, which is 5.886 joule. Okay, so this is the value of the potential energy. Then find the speed at this instant on the water surface. Okay, compare the energy at the top. At the top, it has PE only. And when it goes to the ground level, it has no potential energy, but it has kinetic energy only. So what you can write is PE loss is equal to KE gain. We can only use this relationship when there is no work done. Understand? So what kind of cases there's no work done? Free falling, there's no work done. Pendulum, when you swing something with a piece of string, there is no work done. In these cases, you may make use of PE loss equal to KE gain or opposite. Depends if it's going up or going down, okay? So you may just write down 5.886 equal to half 60 times d squared, okay? neglect the size. We just consider that if there's a size, just like me, I have a height 2 meter or 1.9 meter. So we can't really use the height 10 directly because some positions are at higher position, some positions at lower position. They may not be really correct, exact.
Sure, why are you always using like energy formulas? Why not the velocity formula, the thing?
Because it's
We
easier. It's easier. You know, energy is like a shortcut in handling questions. It makes the question not that complicated, right? Are you using force all the time?
yes. It's
Yeah,
much
you
easier.
can also use that if you can really get to the, you know, sometimes it depends. You have to be very clever.
Sure, I dare you to find the answer of
14
C
meter.
by this method.
Surely I can.
Huh?
Surely I can. Let me show you later. But let's make sure everyone understand how to do A and B. That are the questions everyone should be able to handle to get the basic score, right? Just free falling, converting the KEPE thing. How do you know that there's no work done? Is there any external force, someone pushing it or leaving it? No such force, right? And there's no friction also. So basically, it's only under gravitational force and it is being counted in the potential energy. So you don't need to really consider the work done because there's no force is doing work. Yes?
So we're gonna neglect the air resistance?
Yes, we neglect air resistance. Because if Kenneth has no size, that means there's no air resistance also. Okay? Now let's go to the next part. Now, so now you know that Kenneth has a speed on the water surface, 14 meters per second. So pass C. Wait, let me draw again. This is Kenneth. And U equals 0, V equals to 14.0. And now he would be at the lowest position, 3 meters. A lot to the scale. This is 10 meters, and he reached the when Kenneth reaching the maximum depth, actually, his final velocity would become 0. So I need to find out the resistive force exerted by the water on Kenneth. So we may consider this. Look at my blue pen. Originally, he has 14 meters per second, and at the end, it becomes 0, right? So you may find out the loss in KE. The KE loss is basically equal to half m b squared, which is half 60 times 14 squared, right? We have calculated that before, which is 5886 joule, isn't it? Now, if he has a certain KE, when it dropped here, he lost all his KE. Besides, there is a PE loss also. The PE loss is equal to mgh. His h is only 3 meters. Okay? So which is equal to 60 times 9.81 times 3. Now remember, we are considering the starting point on the water surface and the finishing point at the maximum depth. So both of the KE and PE are losing. It slow down and go to a lower position. So that is the amount of energy. We have 60 times 9.81 times 3, which is 1765.8. Now, both of them are the energy to be lost. It should be taken away from the work done against water resistance, so that water work done against water resistance is equal to the sum of it, 5886 plus 1765.8, right? You need to add both of them to find out the total energy loss, and which is equal to the friction times 3 meters. This is the work done against friction. Friction times displacement. Okay, so you may just add these two together and then divide by 3. 5886 plus 1765.8 divided by 3. Okay. Can you follow actually? Now, so the answer would be around 2600. Okay, now, once again, you're looking for the average resistive force. And this average resistive force is taking away the energy. The energy, and the formula is F times S. This is the amount of energy being taken away or rather against resistive force. And you may consider what kind of energy is being taken away. First, it slows down. That's why you have this amount of energy being taken away when it is going to the maximum depth. And at the same time, the height has been changed. The height is getting lower and lower. That's why there will be a loss in PE also. So when you combine the loss in PE and KE, it should be equal to the energy taken away by the work done against resistive force. So that's why we got the equation in this box. This is the equation we should be able to set up.
Sure.
Yes.
Can you do it the another way, using the acceleration and all that?
You can also using this.
Or can you do it now?
Okay. Now, if we do it by the acceleration thing, now let's try to do that. Can I use a blank screen like this?
Sure, why not?
Now, so let's say you have a 14 meter per second originally, and at the end you got 0, right?
Yeah.
And then it's a resistive force. Now, first, if you do like that, you're using Newton's law.
Yeah.
It has a weight and also has a friction.
Yeah.
So we may find the acceleration first. Okay, no. Let me do it. We find acceleration first by using this distance, 3 meters.
Deceleration.
Yeah, deceleration. If you use acceleration, you have a negative value, okay? Now, so you may find the A first. You got V, you got U, you got S, you find A, you may use this equation. V squared equal to U squared plus 2AS, which is 14 squared equal to, oh, sorry, mistake. It should be 0 squared. 0 squared. Sorry. What I'm doing?
You do drink alcohol just now.
14 square. I'm drinking coffee.
Oh, that's a joke.
It's real coffee. Inside is not alcohol. You know, some teacher put alcohol inside this can. But me, I put. Yes. It's equal to 2 times A times 3. Hey, I forgot. You know, some of you may be having a parents around you. I should not say something about alcohol. Okay, it should become 196 plus 6A equals 0, isn't it? And then A is equal to 196 over 6 negative, which is equal to 32.
Sure. Either you're doing this wrong or the before question you did it wrong.
Which one?
Either you did this wrong or the way you did before was wrong. One of them.
No, not really. You check first. Now this is negative 32.7 meter per second, right?
Yeah.
But this is not yet the answer.
No. Continue. I guarantee you get wrong.
Now look at this. Now you need to set the equation. Net force equal to W minus F equal to MA, isn't it?
Wait, why W?
The weight is downward, the friction is upward.
Sir, we don't have the mass, right?
We have
Yeah.
60.
Oh, okay.
So why
Kenny
do you
is 6.
minus W?
No, it's W minus F.
Yeah, why?
Because there are two forces acting on the person.
Oh, I forgot.
That's why net force is always like finding all the forces and then you do the subtraction to find the net force. So it should become 60 times 9.81 minus F equal to 60 times negative 32.7. So you find the same answer. Yes. Okay, let's try.
Okay.
I think you may miss out this part, right? Isn't it?
Yeah.
Okay.
Yeah.
So whenever there's an object moving up and down, you need to consider all the forces acting on it. There are two forces in this case. Now let's go on. 2 more questions, okay? And then we leave the remaining tomorrow. Question 7. Where's the worksheet? Oh, wait, I get lost, sorry. Yeah, here we are. Oh, William from other class, huh? We have a drink, hot tea at the beginning, and then add some ice cube to it. And it shows the temperature against time. So William stirred the tea through the experiment. Why does he need to do so? To ensure that the temperature is even. Very simple, right? Because your thermometer can only measure the temperature around its the bulb with the liquid, right? So if the water inside do not having a uniform temperature, it would be having a discrepancy in the reading. Maybe the temperature is hotter around the thermometer, so you may have a wrong reading. Okay, this is the first part, and second part, there are 4 points, P, Q, R, S. Which instant the ice cube is being added? Can someone try?
20. Near 20.
What? Which one? P, Q, R, S. Q, yes, very good. When you put the ice, there will be a large temperature difference, and that's why the temperature will drop immediately. So that's why Q is the point where you put the ice. From P to Q, it only cool down by the room temperature, okay? Because the room temperature is lower temperature than the hot tea. That's why it was still dropping in temperature, but not really fast. Okay, then the last one, the second one. The instant at which all ice cube melts. Yes, point R. When all the ice melts, it would reach its lowest temperature, right? This lowest temperature would be lower than the room temperature, and it means that it will absorbing heat from the room temperature. So that's why it will keep increasing. And at the end, what is happening? The temperature is not increasing anymore because it reaches the room temperature. Okay, it becomes stable. What did I do? It becomes stable. So if you mention what is happening from R to S, you will say that the room temperature is higher than the tea temperature at R. That's why it absorbs energy from the surrounding until it reaches the room temperature. Okay, so that's the answer for part C. Okay, and at the end, there's one question, what is room temperature? Temperature of surrounding, you may just estimate this. It's around 27 degrees, okay, or 28. There will be a range accepted, lowering, yes, because it's not very clear from the graph. You will just answer like 27, 28.
Sure.
Okay, yes.
How about nearly 30 degree?
Not good. I won't say it's wrong. You know what? I know that you know what's going on, but try to put a number that is more
Sure, I
reasonable.
wrote 27 Celsius degree and then put nearly 30 Celsius degree.
That's perfectly good, yes. First, you must have a value. You must have a more specific value rather than just lower than 30. Because it could be meant a large range, lower than 30, right? Or around 30. Good. Now let's do also this question before we finish today's section. Okay, like this, we will have a question talking about lens again and again. And it's always a skill, like you need to study these parts. Once you see the nature of image, you should be able to list out what they are. It is inverted, right? Diminished. This is something we should be able to read. And once we know that it's inverted and diminished, immediately we know that it should be a convex lens. And also, we know that now real, yes, it's also real, but when you look at the image, you can't tell it's real. You only can tell it is real because it's inverted, okay? It's also real, very good. The question also asking this, real, diminished, and inverted. And this is convex lens, but also, now I'm not going to the question yet. I just want to see whether you can tell what is the object position. At which position do you have a diminished image? You need to study that, which is beyond 2f, yes, larger than 2f. And the image position is between f to 2f. Yes, very good. Now you should be able to tell this without referring to the notes. This is something we should be able to handle in the test, in the exam, I mean. Okay, so let's answer the question now. State the nature, I circled that already, right? And then, Jason hold a lens in front of paper in figure 5 and finds the image form is of the same nature of it. So what is the lens held by Jason? First, you know that it's convex lens. Okay, let's continue. Sketch a ray diagram so that how the letter has been formed. So that means you may just randomly draw. What I mean randomly is not really so random.
Sir, in the exam, are we gonna draw a ray diagram without the graph? Like we're just gonna draw in the blank space?
If the question says sketch, you just draw in the blank space. But sometimes the question will ask you to complete the, your question in graph paper or on the graph paper shown on the question answer book. You will do it on that. So if the question do not give you any graph paper, you will just sketch it. Okay?
Okay.
Now, so that's why you need to remember where is the position of the object distance. It has to be beyond 2f, right? If you don't study this part, you won't be able to draw this correctly. So once you got this, you will just draw parallel light ray. It passes through F. Draw this line. Try to make it long. Ah, yeah, so ugly. Then never mind. Like this, okay? In exam, you don't do something like this because I can't draw properly with my Apple Pencil. You can use pencil and pen to draw it in a better way. Okay, then draw this. This is the image form. Okay, now I give you one more hint. If I have a straight line coming from this, where will this light ray goes? Do you know?
Towards the point.
Which point?
The arrow. The
Very
image.
good. Someone draw it already. You see, just mean that I can see the words clearly. It's from the bottom of the object, right? That's why it should be going back to the bottom of the image. Okay, last lesson I talked about that, and today I talk about that again, so you know what's going on. Bear in mind, head to head, tail to tail. Any question? Now, if no question, we stop here today. We continue tomorrow, 10:30. Is it okay? Now, so I will upload this revision video to YouTube again, so that you may revise that, especially some parts you don't really clear during the section today. You may try to go through that again, but at least you know what are the topics that are important to you. Okay, now, so if you got a question, you may stay here. If you don't have it, you may say bye to me. Bye-bye.
Sir, for the exam, how can we how do we make use of the time wisely? Like for session A, like how many minutes should we use?
Oh yeah, good question. So we got 2 hours, 30 minutes, right? So that means totally you will be having 150 minutes. So you should spend 50 minutes for MC. So that means it's around 1.5 minutes for each question. Don't spend too much time on one question first, and try to do the questions you have more confidence. I would suggest you to do the heat and the wave questions or the light question first. For the force and motion, you may do it later. And for the long question, totally it will be around 80 marks. You have 100 minutes. So I would suggest you look at the score for each question and spend 1 minute, 1 mark. So let's say if the question has 8 marks, you try to finish that at 8 minutes, so that you may have some spare time for you to do the review. I myself prefer you guys to do the questions you feel confident first. It's not really about long question or short questions. It doesn't matter, but it's the golden rule: don't spend too much time on one question. If you feel confused, just skip that first. Try to finish those you can handle easily. What is AOT? AOT, what's that? What is that? I don't get it.
It's an anime.
Oh, really? Oh, Attack on Titan. I didn't watch it. I watched a little bit. I find the graphic is not nice. Is it like going to be finished? Okay, same time, no anime. Wait until season 4. I know there's Dr. Stone and something else. Yes?
Should
we actually leave the
With what?
Should we actually leave the MC part for the last and like do the long question first?
It depends. Some people may be more confident in MC, but some people may be more confidence on long question. It really depends on different people. But just do the questions you feel more confident first.
And in the online question banks, there's like a lot of physics question. Do you get the question from there, or you make your own physics question for MC?
For MC, I just get it from somewhere.
Is it online question bank?
Online question bank?
Yeah.
I'm not quite sure. Not from this, somewhere from this, some question from this, some question from that, and then combining together. Shingeki no Kyojin. Yes. How come you can memorize the Romanji easier? I think you guys will be good in using English. Shokugeji no Soma. What's that? Soku Deji. Food Wars? What's that? Let me check. All of you know a lot of animes. Soba. Oh, this one, right? Is it about cooking? I heard about the name before. You made me so hungry now, see? So much food. Wow. Okay, let's finish lah. We need to start. Okay, see you tomorrow, 10:30 again. Bye-bye.
Bye-bye, sir. Thank you.
Bye,
Bye.
sir. Are you gonna be the examiner?
Yes, sir.
No. I'm not.
Oh,
Okay.
okay.
Bye-bye.
Bye.
There's gonna be in room 205.
Yes, it's secrets. Okay, bye-bye.
Everyone knows it now.
Oh, really? Okay, bye-bye.
Bye bye.
Bye-bye, sir. Thank you.